Hello, this is 9.04 pre-calc, and we're going to do a little bit more with our ellipses today, and then we will just kind of intro into hyperbolas, but we're not going to go into them too much. So this will kind of wrap up the stuff on the conics, and then we will spend a couple days looking at polar coordinates, and then we'll move on to limits. All right, so again with these, it really helps if you use the grid to kind of graph your points that you're given to try to figure out what's going on in the problem. So if you don't have this sheet and you're using your own paper, I would recommend taking out some graph paper or print out graph paper or draw a graph on your paper. Find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1. So first I'm going to start off by just plotting the points that I'm given. So I'm going to plot the point 0, 1 for one of my foci, and then 1, 2, 3, 4, 1 for my other focus. And then it tells me that I have a major axis of length 6. So again, you want to remember that the foci and the vertices are always both on the major axis. So we know then that our vertices also have to be along this same horizontal line that you see. The entire length of the axis has to be 6. So we know that from the center to one of the vertices, which is your A, is going to be half of that. So you could say from here that we know that 2 times A has to give us 6. So A is 3, because remember again, A is the distance from your vertex to your center. Or you could have just gone right from here and said, oh, well, now I've given my 2 focus points. Let me work my way to the center, find the point directly between them. That's my C. And then if I know the major axis has a length 6, I need to go 3 away from the center on either side. Okay, so I know my graph is going to look something like this, which means it's going to be stretched out more along that horizontal axis. So that's my A. I also know that I can find C here because C is the distance from my vertex to my focus. So if I look from the center, not vertex, center to my focus. So if I count the boxes from here to here, there's 2 boxes. So C must be 2 because that is from your center to your focus. Okay, now we have A and we have C. In order to write this equation, we need to know, well, first of all, we know it's stretched out more horizontally, which means since it's stretched out more along the x-axis, the bigger number is going to go under the x. So I know my formula is x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. And again, A is always bigger, and since it's stretched out along the x-axis or along a line that is horizontal, then we know the bigger number has to go under that. So I know A, I know my center is the point 2, 1. So I know H, I know K, I know A. So these are all things that I'm going to need for this formula. The only thing I don't know is B. So to find B, we're going to use our formula. C squared equals A squared minus B squared. Remember, it's addition in the formula, subtraction to find C. So let's substitute in. We know C is 2, so that's 2 squared. A is 3, so that's 3 squared minus b squared. So we have 4 equals 9 minus b squared. Subtract our 9, we get negative 5. Divide by a negative 1 on both sides, we get 5 equals b squared. So that's what's going to go in right here. So now we have x minus my h, which is 2, quantity squared, over a squared, which is 3 squared is 9, plus y minus k squared, which is right here, so that's 1, over b squared, which is 5, equals 1. And that's your standard form of that equation. Number 2, graph the ellipse given by this equation. List the center, vertices, and foci. Before I can graph this, I need to get it into standard form so I can easily take out what is my center going to be, and I can find my A and my B. So first, this is in like our expanded form. So we're going to have to complete the square a little bit. So first thing I want to do is group my x's and y's together. So x squared plus 6x plus 4y squared minus 8y. And then anything that doesn't have a variable, I'm going to subtract over to the other side. So it equals negative 9. How do I know that if I wasn't told that it's an ellipse? How would I know that by looking at this expanded form of the equation? Well, look at the fact that you have an x squared and a y squared, and the coefficients are different. So before we said the x squared and y squared were being added, but their coefficients were the same, and that's what made it a circle. Now your x squared and your y squared are being added still, so just like a circle, except this x squared has a coefficient of 1 and this y squared has a coefficient of 4. So they have different coefficients. And that's what makes it an ellipse, because it's going to be stretched out on one of those axes more than the other. So just a little note here, different coefficients. Therefore, it's an ellipse, not a circle. All right, so now we're going to complete the square for our x's and for our y's. So over here, let's do x. So I'm going to take my b over 2, quantity squared. My b is 6, and 6 over 2 is 3. 3 squared is 9. So in this set, I'm going to have x squared plus 6x plus 9. And I'm going to make sure I add my 9 over to this side as well. Now I'm going to look at my y's. So before I can do the y's, when we complete the square, it has to have a coefficient of 1. So I need to factor out whatever number's in front of that y squared, even if that means it creates a fraction. In this case, it won't, but it could at some point. So I'm going to take out a 4, which leaves me with y squared. I'm dividing each of these by 4, minus 2y blank. All right, so now I'm going to complete the squares for my y's. So b over 2 quantity squared. I'm going to use my new b, not my old b. So my old b is negative 8. My new b is negative 2, which is negative 2 over 2 is negative 1. 1 squared. Negative 1 quantity squared is 1. So I'm going to add 1 here. Now over here, I'm not just adding 1 over here. I'm adding 4 times 1. That's really important. Remember when we completed the square, we did something like that. So we're adding plus 4 actually over there. All right, now we're just going to rewrite this as a perfect squared binomial. So it's whatever it was before you squared it. So this would be x plus 3 quantity squared, or b over 2, you could think of it as, or what multiplies to 9 and adds to 6, plus 4y, whatever it was before you squared it. So minus 1 quantity squared. Negative 9 plus 4 gives me 4. We're almost there. Now, since we know this is an ellipse based off of the expanded form, or because of the fact that they said to us it's an ellipse, we need to get it equal to 1. And that's really important for our standard form. So we're going to divide everything by 4. So we have x plus 3 quantity squared over 4. These two 4s are going to cancel to give us a 1. And you can write that over 1 if you want to write everything as a fraction, but you don't have to. And 4 divided by 4 is 1. So that's our standard form right here. Set equal to 1. But I still haven't actually given any of the answers to the questions yet. I still need to graph it. I need to list the center, the vertices, and the foci. So let's first start with the center. That should be our fastest one. So the center, we're going to take whatever's being added or subtracted to x and y, and we take the opposite signs, just like we would with a circle. So this would be -3 and +1. Now I've answered a question. On the right track here. So now let's find our vertices, and then we'll work on our foci. So also I'm going to kind of graph this as we go. So -3, 1 is my center. And I want to find my vertices now. So to find my vertices, I need to know and ask yourself, what letter tells me the distance from my center to my vertex? And hopefully in your head, you're saying the A value. So what is our A value? Well, A we know is always the biggest number in the denominator. So this is going to be 4 is equal to A squared. So I have A squared gives me 4, which means A is plus or minus 2. So I know I'm going to go left 2 and right 2 to find my vertices. So now that I've done that, I can just write that off over here. So my vertices are going to be a -5, 1 and -1, 1. And I'm just taking those right off of my graph right here. All right, we're done with vertices. And it then asks us to find the foci. So the foci, you again should be thinking what letter? Hopefully you're saying C. So vertices are the distance, or A represents the distance from the center to your vertex. For the foci, that's going to be our C. Well, we don't have C, so we need to find it. But what do we have? We know A, and we have a B squared from our formula. So our co-vertices on our minor axis, those are our B values, distance from the center to the co-vertex. So if B squared is equal to 1, and I'm getting that right from here, that means B is 1. So if I count up and down from my center, that'll give me my B value. We'll call that co-vertex 1 and CV2. So now I know that my ellipse is going to look like this. So I've also graphed it now. That was something else the question asked. Graph the ellipse. We've got the center, we've got the vertices. We still need to find the foci, which we know are on the same axis as our vertices here, our major axis, and they have to be inside the ellipse. So how do we find them? Well, here's where you're going to use your formula. C squared equals A squared minus B squared. So I'm looking for C squared. I know A squared is 4 and B squared is 1. So C equals the square root of 3. All right, so this is a little tricky to write. So what I want to do first is graph these. So rad 3 is about 1.7, so a little over 1.5. So if I graph those on here, I'm going to go a little, almost to 2 boxes, so right before the vertex. So those are my focus 1 and focus 2. So I need to find the ordered pairs to represent each of those. Okay, so to do that, I know they're all going to be on the y equals 1 line. So I know my y coordinate of each of them is going to be 1. What I need to find is the x coordinate. So it's a weird decimal right here. So the easiest way to do it is to first go to your center. So your center is at -3, +1. So if I'm at -3 right here, and I want to get to focus 1 over here, I know between the center and the focus is going to be radical 3. So I went all the way over 3, so left 3, and then I'm going to go an additional rad 3 in that negative direction. So it'll give me -3 minus another rad 3, since we're going to the left in the negative direction. If I want to find this one over here, This is also rad 3 between my focus and my center. So I'm going to go over to -3, and then I'm going to add rad 3 to it. So let me rewrite that so it doesn't look so funky. So our foci, the x-coordinate will be -3 plus or minus rad 3, and then up 1. And that's really the trickiest part, I think, of these, is figuring out those focus points. So you take the x-coordinate of your center and then add and subtract your C value to that. And then we have answered all of the questions on that one. Next up, we're going to talk about eccentricity, Ika. So eccentricity, or Ika as I remember it, E equals C over A, is used to measure the ovalness of an ellipse. So like how round it is, how stretched out it is. And E is always going to be between 0 and 1. If E is really small, that means the foci are close to the center. It's going to be more circular. If E is closer to 1, so if it's bigger, then the foci are closer to the vertices, it's going to be more elongated. So here, if you have a 0 eccentricity, that means that your foci are on top of the center. And as they get further from your center, your eccentricity is going to go up and closer to 1, becoming more elongated. Find the eccentricity of the ellipse given this equation. So eccentricity, Ika, is E equals C over A. Well, I know A is always the largest number, so my A squared must be 9 here, which means A must be 3. Okay, I also know that the smaller number must be my B squared. So I know that B squared is 4, so B must be 2. Oh, I don't need B, I need C. How do I find C? Well, I use our formula. C squared equals A squared minus B squared. Substitute in 9 minus 4. C squared equals 5. So C equals the square root of 5. And again, we know that they are plus or minus, but we're only looking for those positive distances here. C is rad 5, A is 3, and you're done. So you sub that in for C, you sub that in for A, and that's your eccentricity. And if they ask you for as a decimal, just put it in your calculator to get that decimal. Number 4, write the hyperbola in standard form and identify the center. So now we're just going to do a quick intro into hyperbolas. We're not going to go too much into graphing them. All I want you to be able to do with a hyperbola is put it into standard form and identify the center. So with hyperbolas, again in standard form, just like ellipses, they're going to be set equal to 1. And this is also given to you on your reference sheet. So in order to get this equal to 1, I need to divide every single term by 16 because I want a 1 right there. So 4 over 16 I can reduce to 1/4 x squared minus 1y squared over 16 can't be reduced any further, equals 1. So rewriting it a little neater without those 1s. This would be your standard form, and your center would be whatever's being added to x, which is nothing, and whatever's being added to y, which is nothing, would be 0, 0. And the last one, we have another one. Classify the conic based on the equation, put it into standard form, identify the center. So before we do that, I want to just reiterate how to tell, looking at expanded form, how can I tell which conic it is? So to classify a conic from expanded form, here's what you should be looking for. So if it is, let's start with a parabola, because that one's kind of the one that's different from all of them. You're either going to have an x squared or a y squared, not both. Only one is going to be squared. Okay, if we have a circle, you're going to have an x squared and a y squared. They need to have the same coefficients in front of the x squared and the y squared, and they need to be added together. If it is an ellipse, very similar to a circle, x squared and a y squared, except this time they're going to have different coefficients, and they're going to be added together as well. And then our new one here, the hyperbola, what makes that stand out is the signs between them. So you're still going to have an x squared and a y squared, except this time it's going to be subtraction. And that's what's going to make that one different. The x squared and the y squared will be subtracted from each other. So if you look here, we have an x squared, we have a y squared, and one's positive, one's negative. So that's what tells us it's going to be a hyperbola. So this is a hyperbola, and that's because you've got an x squared, a y squared, and subtraction. Okay, so now let's put this into standard form. So we're going to group our x's together, 4x squared plus 8x minus 3y squared, no other y's, and then I'm going to take that 16, since there's no variable attached, and subtract it over to the other side. So now I want to complete the square for my x's. Whenever I complete the square, I have to have a 1 in front of the x squared. This one's a 4, so I'm going to factor out the 4, which means I'm dividing each of these x terms by 4, leaving me with x squared plus 2x blank minus 3y squared. There's no other y here, so I'm not going to complete the square for the y's. I'm just going to leave it as negative 3y squared. Now I'm going to do my b over 2 quantity squared. So I'm going to do 2 over 2 squared, which is my new b, not my old b. 1 squared is 1. Add 1 here, but really I'm adding 4 to the left-hand side. Rewrite it as a perfect squared binomial. Add negative 16 and 4 together to get negative 12. And then since this is a hyperbola, you need to remember that standard form has to be set equal to 1. So I'm going to divide everything through by negative 12 and reduce. So 4 over negative 12 gives me negative 1/3. Negative divided by negative is going to be a positive, and 3 goes into 12 4 times. So plus y squared over 4, and negative 12 over negative 12 is 1. And for standard form of a hyperbola, you always want to write the positive one first. So it'd be y squared over 4 minus x plus 1 quantity squared over 3 equals 1 would be your final answer. And then I asked you to identify the center. So here's where it can be tricky, because you always write the positive one first. That's not necessarily always the x. So make sure you take from the x first, though, when you're writing your x coordinate of your center. So the opposite sign would be negative 1, and then nothing's being added to y, so that would be 0. And that tends to trick students a lot, so be really careful of that fact. All right, and that wraps up the 9.04 notes for you. And I hope you are all staying healthy and strong and having lots of fun and doing lots of math and loving it. And pie out.